Okay, finishing this problem up. So graph the integrand. We did that old-fashioned way. I don't care how you graph it, just get the graph. And then it said use areas to evaluate the integral. So we looked at that, and the graph, which is in blue, it's above the x-axis, so that's going to be the area. Now you got a couple choices here. That's a trapezoid, and if you know the formula for a trapezoid, you could use a trapezoid. But the way I see it is I see a rectangle and or a square and a triangle is what I see. And so this is going to be area rectangle plus area triangle. So then you want to try to draw a somewhat careful graph. This rectangle right here, 1, 2, 3, 4 units. So 4 units. Over here, my height, 1, 2, 3, 4. 4 units. So it looks like my rectangle is 4 times 4. Then the triangle. Triangle is base times height. And I'll actually write that out in words. Base times height. So I'm going to have 16 plus 1/2. Now the base is still this guy right here. So that's still 4. So I have 1/2 times 4. Then my height, let's see, yellow for my height here. Yeah, you can sort of see that that's yellow. That height. Count the number of units. It's 2 units for that height there. So base times height, and what? That whole thing is going to be 20. And so that integral is 20. Because we were able to view it, since it was above the x-axis, we were able to view it as area. And then since it was a known geometric shapes, we could just find the integral that way. Okay, the last sort of problem, and I like these sort of problems. In the figure below shows the area of regions bound by the graph y equal f of x and the x-axis. Evaluate the following integrals. So what this is saying, in this first little region there, the area of that region is 10 square units. The area of that region is 7 square units. The area of that region is 5 square units. I'm giving you areas. So then do each one of these things from A to B. Well, A to B, it's above the x-axis. So the integral equals the area. And so that is just 10. Now on a test or quiz, I would just expect you to write the answer 10. That is just a fact I absolutely want you to have memorized, that if my function is above the x-axis, the definite integral equals the area. Okay, B to C. B to C, we're below the x-axis. So area equals the opposite of the definite integral. So in this case, -7. Again, on a test or quiz, I'm just expecting you to write -7 because I expect you to absolutely know that when my region is below the x-axis, the definite integral gives me the opposite of the area. A to D. So a little harder, but we will approach it this way. A to B of f of x dx plus B to C of f of x dx plus, lost my train of thought, C to D of f of x dx. And then we can do each one of those. A to B, above the x-axis. So 10. B to C, below the x-axis. So -7. C to D above. So plus 5, and what that equals 8. Then this last guy. Okay, D to C. Notice that's going backwards. We like when we're thinking in terms of area, and that's what we have to think about here, because that's the information we're given. When we are thinking in terms of area, we go left to right, not right to left. So this is going the wrong way in order to think of area. So I will immediately say that that's the opposite of C to D of f of x dx, because if I want to think area, it's left to right. And I have to think area because they told me about area. So make it left to right, so interchange the limits negates the integral. So that negative is just going to hang out, and then just looking at that, that's above the x-axis. Just looking at the integral itself, that's above the x-axis. If I'm above the x-axis, the definite integral equals the area, and so that has to be negative 5. And that is the end of this section.